Hello everyone, welcome back to another video. In this video, we'll be going through a continuation of the previous video, which was about profits and discounts. So in this video, we'll be talking about ratios, rates, and best buys. I'll just write that down. Ratios, rates, best buys. So before we get on with this video, if you haven't liked and subscribed already, be sure to do that now, as it really does motivate me to create more videos. Anyway, let's get on with the video. So for starters, let's set some key ideas down. And the first key idea that I want to tell you is about ratios. So the ratio of something is can essentially be put in a fraction form. So the ratio of, let's say, A to B, which is how a ratio would be written, that can also be written as A over B. Okay, and another thing that I want to point out is that ratios in simplest form use whole numbers that have no common factor. So what I mean by this is, if we have a ratio of 2 and 3, both of these numbers are whole numbers that have no common factor. So 2 and 3 don't have a common factor. If it was to be, let's say, 4 and 6, they would have a common factor of 2. Therefore, it would not be a ratio in simplest form. Okay? And another thing that I want to tell you is something about rates. So what is a rate at the start? Well, a rate is something that compares related quantities with different units. So a rate would be something like 50 kilometers per hour. So here the rate would be, it would have two different units, so kilometers and hours, and it would be written usually with one quantity, which is 50 right here. Okay, so that's what a rate is. And another thing that I want to say is that ratios and rates, they can both be used to determine best buys when purchasing products. And a best buy is the buy that is the best deal for a customer or the person who's buying. So essentially it's the cheapest deal. Okay, so let's get on with some questions. At the start, I want to show you how to simplify ratios. So let's say we've got the question 44 over 8. Now, how do we simplify this? Well, first we need to find a common factor that both of these are divisible by. So we can easily put this in fraction form, if you will, and we can make this 44 over 8, since 44 is the A and while 8 is B. So that would be therefore A over B. So now 44 over 8, well, we can see that 4 is a common factor. So if we do 44 divided by 4 times 8 divided by 8 divided by 4 divided by 4, that would equal 11 over 2. So that would be that would be our fraction in simplest form. Now to put that back into a ratio, we know that this is A and this is B. So to make A over B, you'd simply have to put it as this. So therefore our answer would then be 11 over 2 as our simplest form. Okay, let's try another question. So let's say we're tasked with 42 over 28. Again, in this solution, in this question, we try to find a common factor that both of these can be divisible by, and then we divide it. So we can put this in fraction form, and it would be 42 over 28, since 42 equals A while 28 equals B, and A to B would be like this, A over B. So then 42 over 28, well, we can see that both of these can be divisible by 7 or even 14 if you want to take it a bit more complicated. So let's just do it with 7. So 42 divided by 7 and 28 divided by 7, that would equal 6 over 4. Now, we can still simplify this a bit further, and you can see that both of these have a factor of 2. So if we divide both sides by 2 now, it would equal 3 by 2. So that would be our fraction in simplest form, and to put that back into a ratio, that would equal 3 to 2. Now that we've found solving ratios with whole numbers, what are ratios with fractions? So what if we had something like 1.5 is to 3, let me write this again, 3 1/3. Now this question may seem daunting to a few of you, but let's just think about this realistically. If we put both of these into an improper fraction form, this number would equal 3 over 2, while this number would equal 10 over 3. Now, what this basically equals is 3 over 2 divided by 10 over 3, right? Because this is A and this is B. So it would essentially be A divided by B. So that's basically what it is. So now we can put this into multiplication form, and we would do then 3 over 2 times 3 over 10. And that then equals 9 over 20. So that's our ratio, that's our fraction. And if we want to put this back into ratio form, it would be 9 to 20. And that's our answer, because that's our answer in simplest form, because there's no other way where we can simplify this. There is no other factor for both of these numbers. So let's try another one of these fraction ratio questions. Let's do something like 2 to 1 4. Sorry, 2 to 1 4 to 1 and 2 fifths. Again, we can't think of this question too much. We simply need to put both of these into an improper fraction and then divide it, just like A divided by B, okay? So 2 and 1/4, that would basically be 9 over 4, while 1 and 2 fifths would be 7 over 5, right? And once again, this is A and this is B. So we can do A divided by B, which would be 9 over 4 divided by 7 over 5. Now we can put this into multiplication form, which would be 9 over 4 times 5 over 7. And that would then equal 45 over 28. Now, we know that 45 is A and 28 is B. Now we have to find a common factor that both of these numbers can be divided by. Can you think of any common factors? Well, if you know your multiplication well enough, you would see that there isn't actually any other common factors that both of these numbers can be divisible by. So now we would just convert this back into ratio form. So it would then equal 45 to 28. So there's our answer. So enough of the fractional ratio questions. Let's go through a bit of decimal ratios, okay? So we already know how to do simplifying, such as 6 to 30, but what about 0.3 to 0.9? Now, again, this could look a bit daunting, but if you think about it, we could easily convert this ratio into we could easily convert both of the numbers in this ratio into a whole number. And do you know how we do this? Well, we can multiply both of these numbers by 10, and then we'll get a whole number. So 0.3 times 10 to 0.9 times 10. And that's exactly the same thing, because these 10s will cancel out. So if we go through with this, it would equal 3 to 9. And now it becomes a lot more easier, and we can see, and then we can put it back into fractional form. So 3 over 9. And then we can divide both sides by 3. And therefore that will equal 1 over 3. And then we put it back into ratio form. And there's our answer. So while these questions can look a bit confusing at the start, if you understand how to do it, it really gets very easy. Okay, let's try 2 more and then we'll call it for a day. So what if there is an uneven amount of decimal places? What I mean by that is, what if there was a question such as this, 0.4 to 0.12? So now we can see here that there is only one decimal place before, there's only one number after a decimal place, but here there's 2 numbers. So what will we do here? Well, our goal is to make it easier for ourselves, and the way we make it easier for ourselves is to make sure both numbers are whole numbers. Now, if we only times both sides by 10, they would not both be whole numbers. It would look like this. However, if we times it by 10 one more time, it would look like this. 40 to 12. So that makes our life a lot more easier. So it's okay to multiply the numbers by something more than 10 as long as they're both whole numbers. So to satisfy this, if we times both sides by 100, this 0.112 here will actually become a whole number, as opposed to if we multiplied it by 10. So if we times both by 100, it would be 0.4 times 100 is to 0.12 times 100, and now that would equal 40 is to 12. Once again, we can put this into a fractional form, and that would equal 40 over 12, and we can see that both of these numbers can be divided by 4. And if we divide both sides by 4, it would equal 10 over 3. Now we don't find any more factors that both of these can be divided by, so we convert it back into a ratio, which would then equal 10 over 3. Now, let's go on to something called best buys. So the way we can use ratios to help us in best buys is to see which one is the smaller number. So I'll just use one question as an example. So would you rather have 7 kg of onions for $5.60, or 5 kg of onions for $4.25? So how do we solve these kind of questions? Well, when you think about this, we can put both of these into ratios. So we can put this into 7-5.6, right? So now we can use 7 as A and 5.6 as B, and put it into a fraction, and that would then equal 7 over 5.6. Now, if you know your division, you would find that if we divide both sides by 7, it would still work. So 7 divided by 7, and then 5.6 divided by 7, that equal 1 over 0.8, right? So therefore, we put it back into a ratio form, and we would see that 1 is to $0.80. So then we can see that 1 kg would equal 80 cents. So that's how we found the amount for 1 kg for this problem. Now we do the same for this, and then we can find which one is the better buy. So 5 kg for $4.25. So then we can do 5-4.25, where 5 is A, 4.25 is B, and this would then equal 524.25. And you would notice if you divide both sides by 5, this side would equal 1, right? So it would be 1 kg equals a certain amount of dollars. Okay, so 5 divided by 5 and 4.25 divided by 5. Now, if you do your calculations correctly, you would find that the answer is 1 over, well, 4, you can't actually do it, 4.2, that would be 8.5. Sorry, 0.85, excuse me, 0.85, right? So now we put this back into a ratio form, and we would find 1 kg equals $0.85. So now we can compare the two. So for this price, it would equal 1 for $0.80. How for this price, it would equal 1 for $0.85. So the way we figure out the best buy is by finding which one is cheaper, and we know that 80 cents is cheaper than 85, and therefore the top number is the answer. So therefore 7 kgs for $5.60 is the answer, since this simplifies into this, and this is the cheaper option. Okay, so I hope you've learned something today in this video. If you've enjoyed this video, be sure to like, subscribe, and comment down below what you want me to do. Until next time, keep on learning.